0 and the minimum cost is 0 starting from the vertex 12. Now we are going to find for the minimum cost for the vertex 9, which is in stage 4, right? So you can see that from stage 4 to reach 12, the edge cost is 4. So we are, that is W of J, K. What is J and K over here? In this case, J is 9 and K is 12. Got it? So if you want, you can write J, K. In this case, the weight of the edge is 4 plus cost of I plus 1. I plus 1 indicate the stage, right? Kth vertex in I plus 1th stage. You know that I in this case is 4. 4 plus 1 is 5, right? So our K, which is our K here now, 12. 12 is in stage 5. What is the minimum cost of the node 12 in stage 5? So you can see that in stage 5, the node 12 is having the minimum cost of 0. So you are writing it as 0. As I told before, here we don't have one more edge to find the minimum. It's only 4 plus 0, comma, nothing is there, no more edges are there. So we are writing the minimum is same as 4. So what is the minimum cost of the node 9? Minimum cost of node 9 is 4, right? This 4, okay, this is stage number. And from where it is, like to reach where it is, like to reach 12. Got it? I hope this is clear. Now we will continue the same for the next edge, which is starting from stage 4, that is from the vertex 10 towards the vertex 12, which is in stage 5. Got it? So here also, what is our J this time? J is 10 and K is same as our 12. So what is the minimum cost of the vertex 10 in stage number 4? Here it was 9 in stage number 4. Here it is 10 in stage number 4. What is the edge cost? W of GK. J is 10 now. So what is the edge cost? From 10 to 12 we have the edge cost as 2 plus. Now what is cost of I plus 1? K. You know that in I plus K in I plus 1 stage, that is stage 5. What is the cost? Here we have calculated the cost as 0, right? We are writing it as 0. As I told, we don't have any other edge to find the minimum of these two. And now the minimum cost of this vertex is 2. So we are updating in the table it as 2 to reach the vertex 12. Got it? Now, which is the other vertex in stage 4? 11 is the next vertex, which is in stage 4. So we are going to find the cost of vertex 11 in stage 4, which is nothing but minimum of. What is J comma K this time? Here now J is 11 and K is 12. What is the edge cost? For the edge from 11 to 12, it is 5, right? So we are writing 5 plus. What is the cost of I plus 1K? Here for all these three, this I plus 1K, the kth vertex in I plus 1 stage is nothing but our 12 itself. What is the cost? We are already calculated and kept, that is 0. That's why we, on all cases, to reach the 12th vertex, which is in 5th stage, right? 5 plus 0, comma. We don't have any other edge to compare and take the minimum. So here it is 5. So the minimum cost is 5 to reach 12 from the vertex 11. Is it clear? So we finished now all the vertices, all three vertices, 9, 10 and 11. 9, 10 and 11. We calculated the minimum cost to reach the sync vertex 12. Got it? So now we are moving on to the next stage, stage 3. What are the vertices which are present in stage 3? 6, 7 and 8. So we are writing in the table vertex 6 in stage 3, vertex 7 in stage 3, vertex 8 in stage 3. Is it clear? So here now we are moving on to the next this thing. We cannot write over here, no? Okay. So I think you might have copied all these values, right? If I remove, it will be going off. That's why I'm telling.
Yes, ma'am.
So this, when I remove the PPT from slide view, it will go off, let's say. So we have written the minimum cost, and now for these three vertices which was in stage 4, I hope you have written over there. So anyway, I'll copy those at cost alone. Okay. Now we will do for the vertices which are present in the next stage. Which are the vertices? You know that 6, 7, 8, which are in stage 3, we are going to calculate the minimum cost. So what is the minimum cost? Again, applying the formula. So here you are going to calculate the edge cost for vertex 6, which is in stage 3. That's why we are writing 6 in 3. Now you can see there is a difference. Now there is some meaning in finding the minimum cost as given in the definition. Here there are two edges. Listen all of you. There are two edges which are starting from 6. Right? One is towards 9 and the other one is towards 10. Is it clear? So there are two edges. We are going to calculate the minimum cost among these two. Okay. We are supposed to keep the video on. Okay. I know most of you are taking the call in mobile only. No, then what? I don't know why they had asked us to keep the video on, but still. Now these edges which are connecting from 6 to 9 and which edge is having the minimum cost, that we are going to calculate now. Got it? Now we are having the two edges which are starting from vertex 6, which is in stage 3. Understood? We are going to find which is minimum. So now write min, the same definition, minimum of. What is the first thing we have now in the definition? Now I have kept the graph over it. You can see that it is cost of ij. So which is ij? No, cost of ij. We are going to calculate minimum of weight of the edge, which is the edge here, j k. Right? Our k is this now. Understood? Because in the previous step we have already found the minimum cost to reach 12 from the vertex 9. Now we are taking 9 as the destination to reach. Okay, from 6 to 9. So the edge of the cost of the edge from 6 to 9, that we are going to write it over here. So that what is the cost of that edge? 6 plus what is the minimum cost of the edge 9. What is the minimum cost of the edge 9? From the table you can see that I have kept over it. The minimum cost of the vertex 9 is 4. Is it clear? If you have any doubt, I can let you know. So in the table you might have seen that here we have written the minimum cost of each vertex. This is for 9, this is for 10 and this is for 11. Already we calculated the minimum cost for the vertex 9, vertex 10 and vertex 11, right? So we are in the definition you can see that it is nothing but, if you want I'll just keep it down. This you will not be able to see the definition. You have written in your notebook, no? But so here you will be finding the minimum cost. Here already we have found the minimum cost of the vertices. Okay, this much only we need now. Okay, so we are writing the minimum cost. We are finding, so min, and then what is we are going to calculate the minimum cost of vertex 6 in stage 3, right? Vertex 6 in stage 3, these two we are going to find the minimum. It is 6 plus for node 9, you see the minimum cost of 9 is 4, comma, one more edge is which is starting from 6 is towards 10, right? What is the cost of this edge now? 5. And where you are reaching 10, what is the minimum cost of node 10? Node 10 is 2. If anyone is having any doubt, you can message in the chat box. So this is 10 and this is 7, which is minimum 7. We are going to update the minimum cost of the vertex 6 in stage 3 as 7. And this, this is towards 9, vertex 9, this is towards 10. So which is giving us the minimum cost towards the vertex 10. So we are updating it as 10. Any doubts? You can message in the chat box. Okay. Now we are going to calculate the minimum cost for the vertex 7 in stage 3. Again we are using the same formula, min of. So you know that this vertex 7 is also having two edges, one towards 9 and one towards 10, right? So what you are going to do now? We are going to find the minimum of these two edges. So here you can see it is 4. Towards 9 it is 4, right? So we are writing the edge cost as 4 plus what is the minimum cost of the node 9. Minimum cost of node 9 we have already calculated in the table. It is 4, right? So it is 4 plus 4. Edge cost is here, the weight of the edge, the edge is 4 and the node 9 is also 4, comma. Now which is the next edge which is connected to the vertex 7? You can see that in your book also you can see this is the vertex from 7 to 10. What is the edge cost? It is 3 plus what is the node cost of 10? Node cost of 10 from the table you can see it is 12. Oh, it is 2. So it is 8 and 5, which is minimum 5. Is it clear? So this this edge we got like from 7 to reach 9 and 5 plus 3 plus 2 it is for reaching the node 10. So which gave us the minimum. The edge which is going towards the vertex 10 gave us the minimum. 3 plus 2 is 5. So we are going to update minimum cost is 5 and the edge towards the vertex 10 is giving us the minimum cost. Now the third step, now the next line we are going to calculate the cost of vertex 8 in stage 3. In stage from vertex 8 also we have two edges. One is towards 10, the other one is towards 11, right? So we are going to find the minimum of these two, min of, this edge, what is the weight of this edge? 5 plus what is the cost of the vertex 10? We have already calculated vertex 10 is 2. Now what is the cost of this edge from 8 to 11? You know that the edge, we have it as 6 plus what is the cost of the vertex 11? Vertex 11 in the table we have calculated it as 5. 5 plus 2 is 7 and 6 plus 5 is 11. So which among this is minimum? 7, right? Now you can see that this minimum cost is towards the vertex 10 and this is towards the vertex 11, which is giving us the minimum towards the vertex 10. And what is the minimum cost? 7. So we are updating 7 and the vertex 10. Is there any doubt? For now we have finished all the vertices in stage 3. I hope there is no doubt. Same thing I have written in the slide. I am just moving on to the next slide. I hope it is clear. So we have found up to stage 3. Okay. This I have kept as a slide. Okay. Now we are moving on to which stage now? Stage 2. In stage 2, what all vertices we have? In stage 2, we have vertex 2, 3, 4, 5. Okay, so I'll keep it on one side. Down on here. So you will have to tell me in case it is not visible. Okay, I'll keep it in this mode itself, otherwise I cannot type. You people can do in your notebook also, right? So I need not how to make it maximum. Now what is the cost of vertex 2? Listen here. Now vertex 2 in stage 2 is having how many edges? Listen here, this is little more like we have 3 edges now, right? 2 to 6, 2 to 7 and 2 to 8. all 3 vertices in stage 3 is connected by the vertex 2 in stage 2. So we have to find the minimum of 3 costs. Got it? So we are finding which is the first edge. Now we are going to take the edge from 2 to 6. Got it? What is the cost of the vertex 2? We are finding from all these 3. So which is the weight of the edge from 2 to 6? What is the weight? It is 4. Right? 4 plus what is the cost of the vertex 6? That we have already calculated in the previous slide. Got it? So you have to take it from the previous slide. That I'll write down in my note. That is better, no? You people, if you are able to tell me, then it was fine. So otherwise I'll write 6. No, vertex 6, the cost is 7. Vertex 6, the cost is 7. Vertex 7, the cost is 5. And for vertex 8 also the cost is 7. Hope it is clear. Vertex 6, the cost is 7. From the table, you have the table with you. I have, I'm moving on to the next slide. No? For vertex 7, it is 5. And vertex 8 is 7. Got it? So we are using that same cost over here because this vertex which is starting, the edge which is starting from vertex 2 is moving towards vertex 6. So we should add the cost of the edge and the cost of the node. Cost of the edge is 4. Cost of the node is, what is the node weight? It is 7. Right? Now, so cost and writing. Which is the next edge? Which is the next edge? It is starting from 2 towards the vertex 7. What is the edge cost? Edge cost is 2. Right? Edge cost is 2. What is the cost of vertex 7 calculated from the table? It is 5. Now, which is the third edge which is starting from 2? It is towards the vertex 8. What is the cost of this edge from 2 to 8? From 2 to 8 it is 1. Right? It is very small. It is 1. It is 1. Right? So we are writing it as 1. What is cost of the vertex 8? From the table you can see it is 7. Right? So which is minimum now? 4 plus 7. We are going to find the minimum of 4 plus 7. What is 4 plus 7? It is 11. Then 2 plus 5. What is 2 plus 5? 7, comma. And then here it is 1 plus 7. It is 8. Which is minimum here? Minimum is 7. We are going to update the minimum cost as 7. And it is from this, this is from the vertex 6. This is from the vertex 7. And this is from the vertex 8. Right? So which one is giving us a minimum? From vertex 7. So we are going to update it as vertex 7. From vertex 7, it is having the minimum cost of 7 from vertex 2 in stage 2. Similarly, you have to find for vertex from stage 2, the second vertex is 3, right? So from vertex 3, you have 2 edges. One is towards 6 and the other one is towards 7. Got it? Are you having any doubts? If you have any doubts, you can ask. I will also solve for the remaining. Only these many are remaining. So we will solve from 2 to 3. From vertex 3 in stage 2. Vertex 3 in stage 2. We have one edge towards 6. What is the cost of the edge from 3 to 6? 3 to 6, it is 2. Right? Now, what is the cost of the vertex 6? Vertex 6, the cost is, we can take it from the table, it is 7. Now, which is the next edge which is starting from 3? It is from 3 to 7. What is the weight of the edge from 3 to 7? It is 7. What is cost of the vertex 7? From the table, you can see it is 5. So, it is 2 plus 7. What is 2 plus 7? 9. Right? So it is nothing but min of 9 comma, and this is 7 plus 5, it is 12, right? Minimum of 9 and 12. Minimum is 9. We are going to update it as 9. You should know that the first one, no, it is towards which vertex? It is towards 6. This is towards 6. And 12 is towards 7. Right? Which gave us minimum? The edge towards 6. So we are updating it as 6. Now we are going to find the minimum cost for the vertex 4, which is in stage 4. It is having only one edge, just like our first case, right? So we need not find the minimum and all. Minimum, you know that it is same. So one is the edge, you know that only one edge is there from starting from 4 towards the vertex 8. What is the cost of that edge? 11. And what is the cost of the vertex 8? From the table you can see it is, from the table you can see it is 7. So 11 plus 7, it is 18. The minimum cost is 18 and it is from the vertex 8. Are you all doing along or just I am doing for myself? I hope you are doing. Yes, okay. Then if as I am changing the slide now, I may not be knowing. Are you all getting the same? Now for yes, ma'am. Okay, vertex 5 in stage 2. What is the meaning of 2 comma 5? Vertex 5 in stage 2. Vertex 5 in stage 2 is also having two edges. One is towards 7, the other one is towards 8, right? So what is, we are going to see from vertex 5 to 7. 5 to 7, the edge cost is what? 11. Right? And what is the cost of the vertex 7? Vertex 7, we can take it from the table. It is 5. 5, ma'am. Now, for the edge from 5 to 8, the cost is 8. Now, the edge cost is 8. And for the vertex 8 from the table, the vertex cost is what? Vertex cost is 7. Now, so it is 16. You have to find minimum of 16 comma 15, right? So minimum is 15. The first cost is due to the edge from 5 towards 7. The second one is towards 8. The one which gave us minimum is towards 8, right? So we have to write here 8 and the minimum cost is 15. So we finished all the vertices in stage 2. Now we are moving on to the stage 1. Stage 1, we have only one vertex, but the problem is it is having 4 edges, right? We have to find the minimum of these 4 edges. Got it? So now, what is the first edge? It is from vertex 1 to 2. For the edge from vertex 1 to 2, it is 9. Edge cost is 9. And the cost of vertex 2 in stage 2, we have calculated it as 7, right? 7. So we are writing it as 7. We will be getting 2 minimum cost. Okay, now the second one is from 1 to 3. 1 to 3, the edge cost is 7 and the cost of vertex 3 from the table you can see it is 9. Understood? For vertex 3 from the table we have already calculated it is 9. Now the third edge is towards vertex 4. So vertex 4, for vertex 4, from 1 to 4 the edge cost is 3. What is the cost of vertex 4? From the table you can see it is 18. One more I have to draw. One second. Then I am finding like one more is there, right? Which is that edge from 1 to 5. What is the cost from 1 to 5? 1 to 5, 1 minute. What is the edge cost from 1 to 5? It is 2. what is the cost of the vertex 5? Vertex 5 from the table, it is 15. So now we have to find the minimum of all four vertices. Like we are finding the minimum because of all four edges, right? Minimum of 9 plus 7 is 30. 9 plus 7 is what? 16, right? 16. Next is also 16, comma. Then what I deleted something. 3 plus 18 is what? 21. And one more is 2 plus 15 is 17. Which is minimum. Are you all getting like this only?
Yes, ma'am.
What is the minimum cost now? It is 16. But you can see that. So what is the first one? This is from vertex 2. The second one is from vertex 3. Third is from vertex 4. And fourth is from vertex 5. Right? So you have to write, you are getting minimum cost as 16 from two vertices. Which are the two vertices? 2 and 3. So you have to write it here as 2, 3. Okay. So now you are going to find the path which gave us the minimum cost. So the minimum cost, you will be writing it as 16, right? Minimum cost is 16. And then, so finally where we have reached now from vertex 1, right? So you can write one path as, so you can write one path as that vertex, the minimum cost, so from 1 to 2, the next time we will write with the 3, okay? 1 to 2, okay? The other one is from 1 to 3, both are having the minimum cost of 16. 1 second. So here you can write to reach the vertex. You are going in the backward. Now you are going to backtrack. From 1 you have taken. You can either go by 2 or by 3. So first we will see by 2. Okay. So you will be reaching 2. Now from 2 to get the minimum cost. Where is 2? To get the minimum cost, which vertex you have to take? We have to take vertex 7. Got it? So you can write in your notebook 1, 2, 7. Is it clear? 1, 2, 7. And then to reach, to get the minimum cost from 2, we have found it as 7, vertex 7. Now we have to move to the next stage. Here the previous stage, vertex 7, vertex 7 here, right? To get the minimum cost of vertex 7, it is from vertex 10. So after 7, you give comma and give 10. Okay. Now 10. This is the vertex from which it will have a minimum cost towards the vertex 7. Now you are going to see the minimum cost at vertex 10. You will get from the vertex 12. So 10, 12. This is one path which will be giving you the minimum cost. Got it? 1, 2, 7, 10, 12. I hope it is clear. Now we will see which is the other path which is giving us the minimum cost. Here instead of, as I told, minimum cost is given either by 2 or the edge 3, right? Or the vertex 3. So we will take the other way. From vertex 1, we will move to vertex 3, right? So one more, in your notebook, you can just write 1, 3. And to get the minimum cost at the vertex 3, which should be the vertex, the previous vertex should be vertex 6. 1, 3, 6, right? Now you have to move on to the, for me, I have to move to the previous one. For vertex 6, the minimum cost. Here, vertex 6, the minimum cost you will be getting from the vertex 10. So after 6, 10. And then You see in the table, for the vertex 10 in stage 4, you should be starting from vertex 12 with a edge with a minimum cost of 12. So it is 10, 12. There are two minimum or the shortest path. One is via 2, the other one is via 3. So you can see in the graph the minimum cost, whatever we calculated now, that path, it is moving from 1 to 2 to 7. I'll draw it and show. So here the path is one path which is having the minimum cost is from 1 to 2, 2 to 7, and then from 7 to 10, and from 10 to 12. This is one path which is giving us the minimum cost of 16. The other one is from 1 to 3, and then from 3 to 6, then from 6 to 10, from 10 to 12. So you may be thinking from the graph only, Divya will tell now, from the graph only we can calculate. The thing is, we have to imagine that all these are happening. The minimum cost we will be finding in networks, right? Computer networks and all. No, you will be considering all these nodes as servers, right? In networking. So algorithms are implemented, in order to find the shortest path among the servers. Got it? So you will have, in this case, you have two shortest path. If server 2 is done, you make take the packets via server 3. Got it? Okay, hope it is clear. If you have any doubts, you can ask me. So this table, if you draw, it will be more organized, I feel, like this, if you are giving. One more example I am going to give. So this definition, algorithm, I'll try to make it a little more simple and then give you. This will be the definition. Now, if you understand the way how you are doing, then it will be easy for you to write. Understood? The minimum cost of each vertex. The final vertex, in our case, we started from the sink and we calculated for the source vertex. That is vertex 1, right? In stage 1, that will be giving you. So you know that in each time we are finding different, we are making many decisions, right? From I itself we are taking 4 decisions, and out of that, which among that is the minimum cost we are taking, right? So this, you may be thinking why I am telling cost of the vertex ij, jth vertex in ith. This is for the final one. Okay, final one, how we will calculate again for the previous set of vertices in that stage you have to calculate. So 1 in stage 1, that will be the last one which we will be doing. But in each case we will be finding cost of I plus 1, right? If you get cost of I plus 1 only, we will be able to substitute and get it. So that's why we are starting from the sink vertex and backtracking. Or we are going from there, we are making it as forward. The name is forward approach, but we are starting from the sink vertex. Archana, what is that? 1 to 2 is 21, 1 to 3 is 16. Which is that? Archana, can you tell me which is the 21? Calculated the cost. Using 1 to 2 is 21. Huh? Both should be 16. We calculated both are 16 only. That's why we are getting the minimum cost. No, when you do manually also, you should be getting 16. What happened? Deepak, you are getting 16. Deepak, are you getting 16 for both?
16 only,
Yes.
ma'am, it's 16 only. Both are 16.
Okay. If you want, you calculate, that 16 only we should get. Okay.
Ma'am,
Yeah.
Benita ma'am.
Yeah.
Second part you said that it's from 1, 3 to 7. How 7, ma'am?
7 because
Second part.
yeah, second part we are starting from 1 to this 3 we are taking, and then 3 so we have to check for the minimum cost of vertex 3 how we are getting. If you are using that is a mistake, I think.
That is, you took 6, ma'am. It is 7, right?
It should be 6. I gave it as 7.
No, ma'am. It should be 7 only, no, ma'am.
This
You
is,
took 6, ma'am.
yes, it should be 6 only, no?
It should be 6 only, ma'am.
How, ma'am?
Vertex 3
How,
in
ma'am?
stage 2. See in the table, vertex 3 in stage 2. What is the minimum cost? Which is the vertex which will be giving you that minimum cost from vertex 6?
Okay, ma'am. Okay.
Vertex 6, it is not the cost, it is vertex 6. Then we will see in the table for vertex 6 here, vertex 6 in stage 3, to get a minimum cost, you should start from 10, right? Then you have to see vertex 10 in stage 4. To get a minimum cost, you have to start from 12. Like that only I had given. Okay. So all of you, one more graph I am going to give. Do it as a homework. This one. This is having the vertex named as A, B, C, D. And the edge cost is also different. Because this is there in all the question paper, you should do at least once, like you have to do it at home. I'll give you assignment with the questions which are present in the question paper. This graph you just copy. Assignment it will take time. No, by the time you will forget. So once if you do know, this formula also will be by heart. Okay. In case you don't remember the formula by heart, you just try doing it. One edge you do, then you will remember. Okay, so you should remember I and I plus 1, and also that JK. JK is at weight of the edge. Like that, if you do, it will be. Copy the graph. Copy the graph now. So tomorrow it will be there. Now, as I told, you will be having the test for 5 minutes, and I have scheduled it, so you'll have to take it and then submit it. So we'll take attendance with that. I'll also refer to that, not only this one, just logging in and leaving in all, it will not work. Copy the graph fast because less than 1 minute it is showing. I'll again